Okay, welcome to class of physics. In previous video, we have derived an equation for single stage rocket. Now, in this class, I am going to explain about multi-stage rocket and some advantages of multi-stage rocket. Okay, so here there is no equations or any derivations, just theory is there. Okay, multi-stage rockets. Okay, so a multi-stage rocket is a rocket that uses two or more stages, each of which contains its own engines and propellant. So in single stage rocket there is only one engine or a propellant, but in multi-stage rockets we are going to use number of engines and propellants. So there may be a 2, 4, up to 5 we can successfully use these multi-stage rockets. A serial stage is mounted on top of another stage. Okay. Parallel stage is attached alongside another stage. Okay. So here in multi-stage rockets we are going to construct a rocket in two ways. One is serial and another one is parallel. In serial rockets what happens? A engine is connected to another engine. Okay. So top to top or end to end. In parallel multi-stage rockets we are going to attach engines side by side. The result is effectively two or more rockets stacked on the top of or attached next to each other. So by this what happens? We can going to use number of rockets, okay, stacked on top of another. Instead of using different number of rockets, just you are going to use different number of engines in a single vehicles. So that vehicle means in single rocket. Taken together, these are some called launch vehicles. Two-stage rockets are quite common, but rockets with as many as 5 separate stages have been successfully launched. When they run out of propellant, the mass of remaining rocket is decreases. Okay. Assume that the first engine starts working. When the fuel or propellant in that engine is complete, then that will remove itself. What happens? Because of this, the total mass of the rocket is decreases. If mass decreases, then automatically velocity increases. That we call it as acceleration is increases. This stage allows the thrust of the remaining stage to more easily accelerate the rocket to itself final speed and height. Okay. So finally that will accelerate and it will get final speed and height. Okay. So here Saturn 5 launch vehicle. Okay. So here is the model is there. So here we are going to use 3 stages. Okay. So this part is first stage, and next to that is second stage, next to that is third stage, and here we are going to put the instruments and spacecraft. Okay. So all together there is a single rocket. Now when this rocket launches, the first stage starts working, okay, until the whole fuel is burned out. When the whole fuel is burned out, what happens? The second engine starts working, and then this engine will remove itself from that vehicle. Due to this, the mass of this engine will be less to this rocket, then it will accelerate more. And similarly, when this second stage engine is there, so if all fuel is burned out, then it is also removed, and the next stage starts working. Okay. So like that the number of engines will attached in a single vehicle, so that we call it as multi-stage rocket. Okay. Here the model is there how they are working. Okay. So this is first stage. After completion of fuel it will remove, and next this one starts. Okay. So like that finally only the remaining is the instruments in the rocket. So what are the advantages of using this multi-stage rocket? over the single stage rocket. Okay, so here are the advantages are there. The main reason for multi-stage rocket and booster is that once the fuel is exhausted, the space and the structure which contained it and the motor themselves are useless and only add weight to the vehicle, which slow down the future accelerations. Okay. So what happens after fuel burnout? The remaining is useless. Okay, so that will add weight to the remaining part. So this is may cause slow down the future acceleration. For that, by dropping the stages which are no longer useful, the rocket lightens itself. The thrust of the future stage is able to provide more acceleration than if the earlier stages were still attached or single. Large rocket would be capable of, when a stage drop off, the rest of the rocket still traveling near the speed of the whole assembly reached at burnout time. This means that it needs less total fuel to reach a given velocity or altitude. Further advantage is there, so this is important. Further advantage is that each stage can use different types of rocket motors, each turn for a particular operating condition. In particular operating condition means there are different environmental layer is there. Okay, so in Earth atmosphere, after that there is a vacuum. Okay, so in each atmosphere the required engine can be added to the rocket. Thus the lower stage motors are designed for use at atmospheric pressure, while the upper stages can use motors suited near vacuum conditions. Lower stages tend to require more structure than upper, as they need to bear their own weight plus the stages above them. Optimizing the structure of each stage decreases the weight of the total vehicle and provides further advantages. Okay, so these two are the advantages. For this, some concept about multi-stage rocket it completes. Okay, in next class we are going to learn about angular momentum. Okay, so this all concept is about linear momentum, conservation of linear momentum. So further classes we are going to deal with law of conservation of angular momentum. Thank you.